I started this announcement last month. So one of our members here, David Jackson, offered up something really cool for this chapter. So David has published a few articles in ISSA magazine. That's the magazine that comes out once a month from ISSA. So David knows what he's talking about in terms of getting published. He offered his expertise / service to help anybody that would like to get published, or he's even thinking about it, or would just wants to know what the process is, what's entailed. So he's offered up to anybody here, there's nothing formalized yet, so it could be ad hoc, it could be a formalized training. It's kind of who's interested, what they're interested about. But David has offered up his time and his expertise. David, you want to say something a little bit more than that?
Sure. So one of the things that came up is, so I have a different background than a lot of you. I did internet abuse and all of that, and then I went to law school. No worries. So anyway, so I had come up as an information security person, and then I went to law school. And so I, about 4 years ago, came back to ISSA, and I've been looking for a place to sort of, offer my services. And so I've been writing articles for the journal about, I've written about 3 or 4. And so what I thought I would offer is maybe do something like an ad hoc writing workshop where bring your ideas, bring whatever drafts, bring whatever, and like kind of work through a process. And if you want to get published, I know the ISSA journal editor really well and could help facilitate that. They're always looking for articles, so it's not even like it's an issue. It's just more of a logistics of getting your articles to them and the time frame and what have you. So my thought was I could kind of be a bit of a Sherpa and help guide the process for you if you had interest and you wanted to do something, but it just all seemed a little overwhelming. So that's, I've got a small presentation to talk about that, and I'll be talking at one of the upcoming meetings. And then, I'm happy to start, whatever this becomes, kind of in the fall timeframe.
And we're going to put something on our website that you could, and I'm going to talk to our VP of Communications back in the corner there about how to get your name out there if you're interested in doing this. So we actually have your name, and we'll be able to contact you, and hopefully we can work out a convenient time / place. We were talking about virtual, we were talking about in person. So we have to just see what works for everybody's schedule, and obviously David's schedule. But I'll work with Bronco to figure out something on our website that you could go in there and say that you're interested in joining this. This is a free thing that David's offering. There's no cost to this.
Yeah, just people on interest.
Thank you, David.
What's your last name?
Jackson.
So, one other thing that I want to talk about before I forget about it, and that is July 16th. Again, that's the third Tuesday of next month. We have a partnership with the Cybersecurity Summit in DC. They're coming through. It's a full-day conference. They are offering our chapter free slots to attend their conference if you use our code. Our code is up on our website. You have to register ahead of time. It's at the Ritz-Carlton, McLean. Get 6 CPEs out of attending for the full day. This is really geared towards more senior folks. There's some senior folks presenting, and on their website, they're not looking for students to attend. They're actually looking for more senior folks to attend this. Again, it's not our conference. You know, we don't exclude college students or any students, but this one is specifically geared towards more senior folks. You can actually go and see more about the conference by linking through our website to go see what their agenda is, who their speakers are. But it's, again, something that we get to offer our members. So please go out there and take a look. Again, if you're interested, do it sooner than later because we only have X number of spots that are offered to us. Once those spots are gone, I think it's still a discounted rate of $95. But free is always better than $95. So I think they're offering breakfast, lunch, a cocktail hour afterwards, plus speakers look pretty good. There's some panelists as well. So go ahead and take a look out there, see if it's of interest to you. Again, it's in Tyson's, right at Ritz-Carlton. So in terms of our speakers that are coming up, Tom, would you like to say something about any of the next month's speakers that are coming up?
I would love to, but I don't have any at the moment. So I'm working on a speaker for August, which will not be here because our host Alex will be on vacation. So I'm looking for excellent speakers, quality, high quality, good speakers.
So on that topic, you're still figuring out July and August, right?
Yeah.
Okay. So July and August, it won't be here during our normal time frame, which is the third Tuesday of the month. Unfortunately, Alex can't host this. He's got a personal life and he's taken well-deserved vacation. So we're still trying to figure out where we're going to be for July and August. So again, the best place to put that information is the website, as well as the email blasts that come out 2, maybe 3 times a month, give or take. So as soon as we figure it out, we'll let you know. We'll post it on our website. If by chance we can't figure out a location, we'll put that up there as well. We just might not have our meeting for July and for August, but we have to still figure that out internally. If you know of any sites that would host us for July and August, please let me know. Please let anybody on the board know, and we'd be happy to work with you and try to figure that out. Ideally, you would like to keep it the third Tuesday of the month, but we're still open for other ideas and other avenues, other dates. We still would like to keep it in the evening meeting. I think that still works best for everybody.
The 16th of July is the third Tuesday.
Right, but that conference that I just spoke about is during the day.
Yeah, but I thought we were doing it instead of the July meeting. That's fine.
Okay. Okay.
We're flexible.
We're flexible. We're flexible. Again, all that information will be up on the website and in an email.
Simpson is very eager to talk.
So, again, the way the structure is running is any comments, questions, any discussion points, I turn it over to anybody that's here. Mark was kind enough to announce the jobs that are open right now. We also have other jobs that are on the website right now that are listed. If anybody here has any jobs that they know about in IT or cyber, we'll be happy to put those on our website. Or if you know about those now, the floor is yours. Any questions for anybody on the board or for me here? All right, so it's my pleasure to introduce our speaker tonight, SimsonGarfinkel. I'm going to go ahead and read his bio.
Please don't.
Maybe Simpson will talk to, we'll introduce himself then. He's a well-known speaker. He's a teacher.
I'm an
He's a
ISSA member.
professor of this chapter.
Yep.
Yes. You've spoken here, the last time was,
Years ago.
Yeah.
Nobody can remember it.
yeah, that's what I'm asking. I
It's
can't
fine.
remember. I'm getting old.
I remember it. It's fine.
All right, well, Simpson,
Hey, yeah.
please take it over.
Okay, so wow, the mic is on. So I taught a course at George Mason this spring on Mac forensics. And the idea was to just reuse all the slides, but it met every week for 12 weeks. So I went through and I picked out the good slides. You don't have to suffer through all the other ones. If there are any questions, let me know. I'll try to do it in 90 minutes. Is that okay? That's a good time? All right, let's see how this works. So this is Mac OS X forensics. Who here uses a Mac on a regular basis? At work? At home? Okay, so a few people. So basically, I'm going to introduce the course that I taught and give you the history of Mac OS X and why the Mac is different from a forensics point of view. Who here is practicing forensics, just so I know? Okay, like one? All right, well. So you can think of this as also why the Mac is a privacy platform, why you should be using the Mac if you're engaged in criminal activities, as opposed to any other computer system. I'm going to talk about opportunities for forensics on the Mac and then challenges. Feel free to interrupt me at any time. If you think slides are unclear, please email me. Would like to capture that. And the slides are online on my website at simson.net/ref/2019. So the course was to present students concepts, tools, and techniques for forensic analysis of Macs. GMU had this class for some time. It was woefully out of date. Nobody really cared because nobody was teaching it. So then they asked me to teach it. So I had to learn everything about Mac forensics in a few months. And it was hard. I figured, oh, we'll just use the textbook and I'll teach the textbook. But there was no textbook. So then I figured, well, I'll just go to ACM Digital Library and download all the current Mac forensics papers. And there were 2 in the past 10 years. So it was a lot to do. This is the outline of the course that I was able to put together. Encryption, just to bring everybody up to date. Live system analysis, like you're at a Mac and it's been hacked, what do you do? Store data, log files. The storage layer, disk partitioning, working with disk images, processes, network connections, and other stuff. So most of the students in the class didn't really have a clear concept about what a Unix process was and the difference between like a process and a thread, or what a memory map was. We did memory analysis. That turned out to be really hard. Stuff in the user directory, isolation, iTunes. It was just way too much to talk to in a single class. My background, I'm a dilettante. I did 3 degrees at MIT as an undergrad, and then I spent some time as a freelance science writer, and I got bored, so I went back to MIT and got a PhD and faculty at NPS, and then I'm at the US Census Bureau. I'm working on differential privacy. I'd be happy to talk about that some other time. This is not about iOS forensics, which is like iPhones. There's a lot of resources out there for iOS forensics. There are books, there are kits. It's really different on the iPhone than on the desktop. iOS apps are much more restricted. They're limited in what they can do. They're limited in files they can touch. There's much more openness if you're writing apps on the Mac because it's a desktop and they traditionally had no security. The Macs have a lot more functionality, more storage, more history, more compatibility, more APIs. And it's also changing faster than iOS. So Apple is trying to lock down Mac OS X, which they now just call Mac OS. They're making it a more privacy protecting operating system. In the process, it's making forensics harder. And Apple is also adding a lot more identity information. So the operating system knows a lot more about you, who you are, what you do. And that should be creating more opportunities for some kind of forensics analysis. And I don't define forensics in these slides, but if you do identity intelligence, like that's what I used to do, taking people's hard drives and trying to figure out who their friends were and where they hung out so that you could kill them, like drop some steel on their house or something. It's better for that than like trying to do malware analysis. So brief introduction to the Mac. This is a platform that goes back to 1984, 128K Macs. All these systems are basically the same system. They're all running in real mode, cooperative multitasking, no memory protection. The first Mac did actually have this Apple Desktop Bus. So from the very beginning, this idea that you could plug multiple peripherals into machines. And Apple Talk comes out in 1985, so it's the first networked home computer. And they had TCP/IP in 1988. Everything was very proprietary. That ended in 1999 with Mac OS 9. Even here, they're introducing artifacts, things that we really care about, like Apple Keychain, an encrypted storage layer for storing encryption keys and passwords. Back in '99, they had speech synthesis and recognition. They had file encryption. So in 1985, Steve Jobs created Next Computer on the side. They made these black computers made out of magnesium. And when Steve Jobs got thrown out of Apple, he devoted full attention to Next. They had a Unix operating system, a mock kernel, that ran display PostScript. And in '96, Apple purchased Next for $400 million. And the intent was to make Next Step the next generation Apple operating system. So if you have an iPhone, you basically have a Next station in your pocket. And it actually still says copyright Next Computer in some places, and some of the names that still Next stuff there. 2001, Apple brings out the first Mac OS X based on Next Step. And we're now in 2019, so this is like 18 years now, through many, many operating systems. If you want a fun, you can check out the Star Trek project. That was OS 9 on Intel. So one of the features of Next Step is it actually can run on multiple operating systems, multiple hardware. So it can run on Intel and PowerPC. It could also run on MIPS and HP PA-RISC. These days, everybody's pretty much using just two instruction sets, the x86 instruction set and the ARM instruction set. And we're probably, on your iPhone, that's running the ARM microprocessor. And we're probably going to see ARM-based laptops within a year or two running OS X and then probably running Windows. And if you care about how it all fits together, this is a map of all the versions of Unix, starting with Dennis Ritchie's PDP-7. And this is where OS X fits into it. So it's gained some lineage from BSD 4.3, and it's also getting the mock lineage. And it's pretty much its own version of Unix. Here's Linux and Minix. It really is real Unix. It actually has a Unix license. And I have a web page, why Macs are better than PCs, some of the advantages of the Apple side. User interface issues, but also some of the problems on the Windows side. So I just find that the Apple machines to be much more comfortable to use. So the hardware stack today is that there's an Intel chip, and there's some memory, and there's a storage layer, and they can work with pretty much any kind of storage, whether it's ATA or SCSI or USB. Many different multi-purpose buses that can support I/O or memory. Multiple displays that can be directly attached or they can be attached to a bus. Multiple networks, Ethernet, Bluetooth. There is full support for wide area LANs also. and other devices. So it's as powerful an operating system as any server operating system. Any protocol that you can imagine, it's available. There's a version of it on OS X. OS X can, for instance, mount an NFS file system, or it can mount a Samba file system. But it's an open architecture, so you can mount an SSH file system too. When you turn it on, it does kind of what PC hardware does. It does a power on self-test. It actually now does a digitally signed boot. I took out the slides, but it verifies the BIOS with a digital signature, and then it verifies the kernel with a digital signature. So you have secure boot on these machines. It has a whole bunch of special keys that it will look at during boot, which you can change boot behavior. You can set firmware passwords that's supported on all Apple hardware now. If you set a firmware password, you can't boot it into single user mode, and you can't boot the machine in target mode, which means you can't use it as an external hard drive on another computer. One of the reasons I like Macs is you can boot from any partition, and you can make any Mac an external hard drive on any other Mac. And here's a list of the special boot sequences, keys. So you can boot it in like safe mode, single user mode. You can boot it without the GUI, just like Windows, except a little more flexibility. So in terms of forensic opportunities, we're going to look at existing forensics techniques that work on the Mac that you might use from Linux. Now first, any questions about the overall hardware?
I did notice you made a comment which I probably agree with, but I'd like to hear your views on it, on the lousiness of NTFS.
Yeah.
I saw that you.
Yeah, well, let me go back to that page. So NTFS is a lousy file system. It's like, one of the problems is it's very slow. It locks files and directories containing open files. So if I have a file open, you can't rename it, you can't delete it. And if I have a file open at the bottom of the directory tree, you can't rename any directory that that file contains. If that file's on a file server, 200 people in your organization, and one of them has an open file there, you can't do maintenance on that file server. You can't rename any of the files. And that's a feature of NTFS, but it's also really deep. So NTFS in general is just not a good file system. The technical problem is it implements many things in the file system in a mandatory way, which modern operating systems implement at the application layer. And when you implement it in the application layer, you allow applications to do things that they shouldn't, like delete open files, but it produces something that's much more performant. And we tend to care about performance more than correctness. Yes?
Your slide about BSD, and I think it was mock in
Yeah.
terms of the kernel. So what does the mock give you? What kind of features do you get from that?
So the OS X kernel is actually a hybrid kernel. It has a mock microkernel, and then wrapped around it, but still operating inside the kernel, it has a BSD Unix kernel. The original idea of the mock project at CMU was to only have messaging, memory management, and process, the process thread abstraction inside the kernel, and to have every other service, like the file system, outside the kernel. And that makes it more reliable in theory, and it was supposed to make it easier to do research. We couldn't get microkernels to be highly performant because of the problems of doing the message passing. But the mock kernel, as opposed to the mock microkernel, as opposed to the BSD microkernel, is more sophisticated. It offers much more efficient messaging between processes. It offered much better memory management. And so those features are there from mock, but then other features from the Berkeley file system are in the kernel too. So for example, the APFS, the Apple file system, is running inside the kernel. It's not running as a separate process that other processes talk to. And if you have a device driver, the device driver is running inside the kernel. The mock idea was that the device driver would be running at user level, And that user process would have permission to write that the device that it was talking to would be mapped into its memory address space. So,
Thank you.
but it is Berkeley Unix, so you can type Control-T and see what process is running and see the current system load, which is always nice if you're at the command line. It's not System 5. So what are our options for Mac forensics? So there's a web browser, and you can actually get Safari and Google Chrome and Firefox for the Mac. And this is a clever website called netmarketshare.com, and you can tell it desktop operating systems, Mac OS, what's been the current popularity of different browsers. And you'll see that Chrome is 60%, Safari is 35%, and Firefox is 5%. So as a forensic analyst, this means that you need to be able to analyze all three, because anybody whose system you seize might be using any of these browsers, and in fact, I'm using all of them, and I know my wife uses all of them too. She uses different browsers for different purposes. So Chrome allows you to have multiple identities, but she wants some identities that are free of Google, so she has Firefox for another identity. On the hardware, it turns out Safari works the best because of memory power issues. But all the things that are there in a web browser you would expect. So if you go to Safari, there's a rich set of databases, and they're all stored as SQL-like databases. So you can write programs in Python or Java that access SQL-like, and you can write your own analytical tools that go directly to the user databases. It's much easier to do on the Mac than it is on Windows, where you're having to deal with almost undocumented Microsoft databases and dealing with the Windows registry. These are stored as SQL-like databases. So like, you can open them all at the same time and do SQL queries against them all at the same time. You can open up all the users, and there's open source tools that will do that. The Mac implements a kernel tracing system called dtrace. You can basically put hooks on any API. You can say, when this file is opened, the process that opened that file, please capture all the TCP connections that it initiates and all the packets that it sends. And you can compile that trace and put it in the kernel, and then it will run at kernel speed. And so this is something that was developed about 15 years ago, and Apple implements it. Linux now implements it. It's being ported to Windows. It's very, very powerful for analyzing software. You have to disable something called system integrity protection, which is restrictions on the root user. The Apple has this database called File System Events. It's basically a directory that keeps track of every file that is created, deleted, or modified, pretty much for the history of that file system. It's stored in an exceedingly compressed format. So like on my terabyte drive, after a year or two, the FS events, the directory is like 50 or 60 megabytes. So it's tiny. What's it there for? Well, it's there so that if you have like Dropbox, and the Dropbox program isn't running and it starts up, it can figure out which files it needs to index and send to Dropbox. And it's there so Apple's Apple's system-wide search, if it falls behind, if you're doing too much, so it stops indexing files, when the machine is free, it can start indexing files again. It knows which files to look at. So FS Events D is maintained by the file systems. You know, you have to be root to access it, but it's pretty privacy invasive if you think about it. It's a list of all the files and the dates that they were created or modified. There's this database called the keychain. It's a single location where encrypted data is stored. Anything that's sensitive is really kept there, like passwords, 802.11 passwords, encrypted volume passwords, client-side certificates, secure notes. It's one place. You can copy it off the drive, and there's software out there that will try to crack it. John the Ripper supports the Apple keychain format, but the passphrase is hashed 200 or 2,000 times with SHA-256. So John the Ripper can only guess like one password every 2 passwords a second. So it's hard to do a brute force attack on it, but it is possible, and everything's in one place. You can get persistence if you're an attacker. There are many places to get persistence. In the boot sequence, Apple allows you to have, they call agents and they call daemons. Agents are launched when the person logs in, and daemons are launched on system boot. And it has both for the system library provided by Apple, it has ones installed by users, and then users can also have their own agents that get started when they log in. Yes?
Back to the key change, so what's the master key for it? Was it based on user password or?
Yeah, so it's based on the user password and it's entangled with a random password, a random nonce. And then it's it's repeatedly hashed.
So if you do have access to user password, then?
Oh yeah, if you have the user's login password, you can unlock the keychain. So, you ask the person what their password is, and you don't feed them until they give it to you. Right? So I've never actually engaged in torture, just to be
Waterboarding?
clear. I'm sorry?
Waterboarding?
I've never engaged in torture. So. And there are tools for controlling all these. There's the launch control daemon that Apple created, and then it also does cron tab. You can also have your own kernel extensions, although on newer versions of the operating system, Apple is requiring that kernel extensions be digitally signed. And there's just lots of places to put stuff that automatically starts up. So on my machine, there was something like 600 processes running the last time I checked. That was when I logged in. And that's because Apple makes the operating system as a collection of very, very single-purpose processes, each one listening on its own mock port, not consuming any system resources until they're needed, and then they're immediately available. That's one way that the system is responsive. So, any questions on this stuff? So I guess I'm going really fast, so we'll probably be done in like 30 minutes. The point is that there's a lot of opportunities to get data, and if you know how to do forensics on a Linux system, you cannot come up empty on a Mac. You can look for like log files, text log files, and you'll find some. There's more stuff that you'll miss, but you'll find some stuff. Now it's dangerous, though, because it means that people who will do Mac investigations and think that they found all the stuff, and there's a lot more to find. It's surprisingly hard to find all of this stuff. So it turns out that Apple's also creating more opportunities to do forensic collection, but especially what I'm interested in, which is identity intelligence. So I got a new Mac Mini for the course. It used to be that Mac Mini was their low-end machine. Now it's like their medium to high-end machine. My Mac Mini was $2,000. It's got 6 cores, a terabyte SSD. It's got a gigabit Ethernet interface. It's got 4 USB